Hi everyone, can you all see the whiteboard?
Yes.
Perfect. Let's get started. Okay, 380 is correct. Dhanush, can you explain?
So I just took the least number, 2-digit number, so that's 10, and then I did 200 minus 10 equals 190, and then I just doubled it to get 380.
Good, yeah, so that's correct. So if you take the lowest two-digit number of 10, 200 minus that is 190, multiplied by 2 is 380. Good. Now, why did you decide to take the smallest two-digit number instead of like the largest?
Well, I first tried the largest digit number, but that didn't work. So then I tried the least.
Okay, good. Yeah, that works. So yeah, if we think about the largest one, that would be like 99. So 200 minus 99 is 101. And if I multiply that by 2, I get 202. So that's clearly smaller. But if we just think about the two-digit number as, let's call it A. So now 200 minus A is what we get when we subtract it from 200. And when we double it, we multiply this by 2. So we get 400 minus 2A is the value that we get. So now we want to basically make this as large as possible. So if we want to make 400 minus 2A as large as possible, does A need to be a small number or a big number?
Small number.
Yeah. So we want to make this as small as possible to make 400 minus 2A a large number. So if you do it this way, you see immediately that we want to set A to be the smallest two-digit number rather than the largest. Otherwise, it might not be clear just from reading this, okay, should I pick a small two-digit number or a large two-digit number to get the largest possible number at the end of this? So one way is kind of you set this as a variable and look at the expression at the end. How do we make this as large as possible? Any questions?
I have a question. I used for the integer, I got 598 because I used the integer negative 99 so that it would cancel out to be a positive. And then.
Okay, yeah, that's a good thing. So I think the question is not clear in that it should have actually specified two-digit positive integer.
Okay.
So yeah, that's a good observation. I guess if we allowed two-digit negative integer, then yes, 200 you could do plus 99 there, or minus negative 99 as A, which would lead to 598. That's a good catch.
Okay.
Okay. Any other questions? Okay, let's go to the next one. Okay, good. 7 is correct. Nidhi or Neil, can you explain?
Yeah, so I just took first the base set of how it would be without this. So the three main parts of this are the mean should be 5, the median should be 5, and the mode should be 8. And just right off the bat, I knew by looking at it 2, 5, 8, 8 was 1. But obviously that means that the mode is both 2 and 8, and we want a mode that's only 8. So then I just changed that to 1, 3, 5, 8, and 8. And that worked out, that checked out all the things. So then I did 8 minus 1 to get 7.
Good. Yep, that's correct. So let's just walk through how we get the 22588 or 13588. So we'll start with each kind of piece. So let's start with median is 5. So if there's 5 positive integers, and if I put them in order, if the median is 5, that means the middle number is 5. So I think that's the easiest one to fill in. And we also know the mode is 8. So that means it's the most common number So it must appear at least 2 times. And if we know the median is 5, it can't appear more than 2 times. So we know that these two numbers will be 8. So we know 5, 8, 8 are the numbers. Now to get the first two, we know the last piece of information is our mean, right? Or the average is 5. So the sum of the numbers will be 5 times 5, or 25. So what does that tell us about the sum of the first two?
They need to add up to 4.
Good. So we know the last 3 add up to 21. So the first 2 must add up to 4. Now, so one option would be the 2 and 2. But the problem here is that, again, we no longer have a unique mode of 2, or the only mode is not 8. The mode also would be 2 here. There would be 2 and 8 are both appearing twice. So that doesn't actually work. We know the sum of the first 2 has to be 4, and it has to be positive integers. So what 2 other numbers add up to 4 would be 1 and 3. So we know the numbers must be 1, 3, 5, 8, 8. And we can check median is 5, mode is 8, mean is 5, so everything checks out. Now we just want the difference between the largest and smallest integers in the set. Largest is 8, smallest is 1, the difference is 7. Any questions on this?
No.
Okay, let's move on to the last one. Any ideas on this question? Okay, so this is a harder question. Let's start off by, does somebody want to draw kind of some examples of what a chord, kind of where the 2 points should be such that the chord intersects the inner circle versus doesn't intersect the circle?
Can you go over what a concentric circle is first? I don't really understand.
Okay, let's start with that. Okay, so concentric circle just means they have the same center. So let's draw this out. So one circle is like this, and one circle is like this. Okay, and we know one of the radiuses is 1 and one of the radiuses is 2. Okay, so let me mark the, so this radius is 1 and this radius is 2. Okay, so now that we have that, so what we're saying is we're going to choose 2 points independently on the outer circle. So let's say we pick this point and this point. So if we just pick these 2 points, the chord connecting them would be this line, and this doesn't intersect the inner circle, right? So for instance, this could be here. This also doesn't intersect the inner circle. It could be here. This doesn't intersect the inner circle. But if I put this one, this intersects the inner circle. Or this intersects the inner circle. Or this, or, sorry, one second. Or this would intersect the inner circle. And again, it would no longer intersect if it was like this. Okay, does this make sense so far?
Yes.
Okay. Now, to make the problem simpler, let's say I'll pick one specific point. And it doesn't matter where on the circle, let's just call this point A, the left end of this chord that I've just drawn. Now, for some points, if I pick B currently to be where I've drawn this line now, it wouldn't intersect, right? But if I pick B directly opposite A, it would intersect. So let's try to figure out where on the circle B needs to be such that it does intersect. Kind of what is that boundary point? Any ideas? So let's start moving this along. When does this start intersecting B? When does it start intersecting the inner circle?
When it touches it,
Good.
or when it goes through it.
Yes, when it just touches it. So what is true? So just at this point, right? So does anyone know what this is called?
And tangent.
Tangent, good. Any properties, does anyone know of what happens when a line is tangent to a circle? Okay, so what is true when I have a tangent is if I take the radius of the inner circle, this is perpendicular to the chord. These two are perpendicular and they form a right triangle. Okay, so we have some portion fixed here. Now let's do the same thing on the other side. So we figured out, so let's see where else on the other side does the point need to be such that it intersects the circle. So again, if I picked a point here or here or here, these are not going to intersect the circle. Where will it start to intersect the circle?
When it touches the circumference of the inner circle.
Yes, and that happens again at what point?
I think that it's forming an equilateral triangle.
It does, you're right. So we will actually see why, but you're right, it does actually form an equilateral triangle. Okay, so let's see. So let's assume it does form an equilateral triangle. So what would the answer be then? Actually, that might make it easier to find what the answer is.
One-third?
Good, yes, the answer would actually be 1/3. And now let's see why. Okay, so first of all, so I won't show you exactly why it is an equilateral triangle. I know it looks like this for now, and let's just assume that's correct. So now this first point is A. So where should the second point be now for it to intersect? So we know if B is anywhere in this arc, from here to here, this will not intersect. If it starts from here to here, we know it will intersect. Because at this point it's tangent. If I go anywhere further, it'll hit the circle at 2 points, all the way up until it reaches this side tangent. So if I could draw a line here or here, it'll still hit at 2 points. Here it'll touch at exactly 1 on the tangent, and anywhere past that, it won't intersect the circle at all. So now you can make this look like an equilateral triangle by closing this third side. Now we can see it looks like an equilateral triangle. So that means that this, so if it's an equilateral triangle, each of kind of these arcs must be 1/3 of the circle, right? And kind of another way of seeing this is, what is each angle of an equilateral triangle?
60 degrees.
60 degrees. Okay, so we know that this angle inside here is 60 degrees. Now, can we use this to find this angle? So this is the angle from at the center of the larger circle across that arc, the arc that we want, which is the arc which would kind of give us points that intersect. Any ideas?
Can you say it again? Sorry.
Sure. So if we know that this angle is 60 degrees, could that help us find this angle? Let me mark it up, this angle here. And the reason why we want this angle is this is the percentage of the entire circle which we're interested in, right? This part of this arc of the circle.
It looks like it's an isosceles triangle, so I don't know if we're allowed to assume that, but if we do assume that, then we will know that the right top, the half of that right top is a 30 degree, and that bottom is also 30. So then 180 minus 30 is 120. So that would be that angle.
Good. So the number is correct, 120, and you are right that these are 30 degrees. But I think we don't know that necessarily directly from this. So you could construct an isosceles triangle where these points are maybe a little bit further out, where it's not actually 30 degrees. But I think another way you can think about this is, how does this angle relate to this angle?
Is it? I think another way could be a circle is 360 degrees, and that's a third of a circle.
Yeah, so that also works, because if we take this as an equilateral triangle, then kind of we're dividing into 3 arcs, which are the same. So this would be 120 degrees. But now there's another kind of way to look at it, is that this angle, so whenever I pick 2 points in a circle, the angle formed at the edge of the circle, which is this angle, will be 1/2 the angle at the center of the circle. So if this angle is 60 degrees, this angle will be 120 degrees. And this works for any arc. So if this inside angle was 10 degrees, the outer angle would be half of that. So the relationship between these 2 angles is 60 and 120. So that's one way of kind of looking at it. But there's one step I kind of skipped over, and it looked like an equilateral triangle, so we assumed it's an equilateral triangle. I'm just going to kind of go over this piece a bit more to make sure we are kind of seeing why it is. So let's go back to kind of the tangent point that we had before. So from the tangent, what we knew was that this is a right angle, forms a right angle with the radius. Now let's fill in the lengths that we know. So we know that this length is, what is this length?
1,
This point to this point, good. This is 1. What about this one?
2.
Why 2?
That's also given that the radii is 2 of the larger circle.
Good. Okay, yeah, so this is all information we're given, right? So we know that there's a right angle there. We know it's 1, this is 1, and this is 2. And let's assume we don't know it's a right angle. We don't know it's an equilateral triangle yet. So we're trying to figure out what the angles are. Okay, so if I know that this is 1, this is 2, and this is a right angle, does anyone know any kind of properties of some special right triangles that are useful here?
Do we know that this is a 30, 60, 90?
Good. Why is it a 30, 60, 90 triangle?
Because, well, we know the right angle, we know that it's half of the 60 on that side, and then we can do from the triangle sum theorem that the middle angle is 9, or the angle at above, the angle above the right angle, right there, yeah, is 60 degrees.
Good.
And then we can use, there's a property that if the 1 is the, you want to say it? Yeah. Okay, you can say it. It's 2 so the angle is a 2. Yeah. Okay. But I just, so if 1 is x, then the hypotenuse is always 2x of the 30, 60, 90, and then that other long side is square root of 3x.
Good. Yeah, that's exactly correct. So the key, kind of the trick here, once you create these tangents, is actually to look at the lengths, and you figure out this has to be a 30, 60, 90 triangle. And from that, we can figure out, so let's fill this in, because we know that this side is 1 and this side is 2, and it's a right triangle. We know this kind of relation between sides only happens in a 30, 60, 90 triangle. And kind of, if you've seen anything in trigonometry, you can use this, but just a 30, 60, 90 triangle is sufficient. So we know this is a 30, 60, 90 triangle. So we can do, again, the same thing if you repeat it on the other side. We could just draw this radii, and you get the same thing. So this creates another 30, 60, 90 triangle here. So if you add that up, this angle is 60 degrees. Now we can repeat that on this side, we can repeat that on this side, and we see each of the angles are 60 degrees. Now we know for sure this is an equilateral triangle. And then either you can see that, okay, it's an equilateral triangle, so each must be, all of these arcs are the same, this, this, and this, or use this kind of idea that the angle in the center of any arc is double the angle formed at the edge of the circle. So if this is 60 degrees, this angle is 120 degrees. So now basically if I pick any point on the circle, the second point, in order to intersect the inner circle, must be in this arc. So basically if I pick any point, it doesn't matter where this original point is, the other point would have to be within 1/3 of the circle. That means that the probability of choosing 2 points where the inner circle, where it intersects the inner circle, is just 1/3, because given any one point, there's a 1/3 probability that the other point will intersect the circle, inner circle. Does this make sense?
Yes.
it makes
Okay, any questions? Okay, that's it for today's class then. We'll see you all next week.
Bye. Have
Thank
a good
you.
day. Thank
Bye.
you. Bye. Thank you.